Hello and welcome to Statistics for Business 1. I'm Shankar Venkatgiri, your course instructor, and I'm very happy to have you here with me today.
You know me. Yup, Liza.
The last week, we introduced you to descriptive analysis. We learned how to download data from the web, clean it, and begin to visualize trends. Along the way, we spoke about summary statistics for location and dispersion.
Like mean and standard deviation?
Right. In this session, we will begin by downloading another small data set and aggregating it into bins. Then we'll construct analogs for some of the summary measures that we have discussed earlier. You know what they are. Let's begin our segment with a variable which is usually a column in our data set.
So, why is it called a variable?
Good question, Lisa. Anything that varies is a variable. Now, if there is no variation, then from the point of view of statistics, it's quite boring.
So, can it assume negative values?
Absolutely. Why not? If you have a profit and loss data set for a large conglomerate, it's likely that some of the business units are running at a loss, and that is reflected as a negative number. Moving on, variables come in two broad categories. Discrete variables are those variables whose values we arrive at by counting. For example, the number of countries in a region or the number of checks that bounce at a bank on any given day. Continuous variables are those that we can measure, such as the time between successive breakdowns of a machine or the closing price of a stock. Before we proceed, let me point you to a website that I have downloaded today's data set from. This is the World Bank website. For our session, we will be exploring a data set that lists the average gasoline price across different countries. All the prices are in US dollars per liter of gasoline. I'll save you the trouble of cleaning up the data because I've already done that and I'm making it available to you all separately. I'll now go ahead and open up the spreadsheet so we can examine everything there. So here is my spreadsheet that I call gaspricedemo.xls, and I have several tabs over here. The first is the data tab, which has data for gas prices starting 1992, and after that there are a few gaps in the columns, and then the pattern becomes one of having data for every even year. Please keep this in mind. So this is my data set, and then I have the metadata which attaches a country code, a region and an income group for every country over there. We are quite familiar with the scheme of these World Bank data sets, right? Now, I make it a habit of not touching the original data, so there's a copy of it under the Analysis tab. So there's my Analysis tab, and what do you notice? I have sort of cleaned up everything and only considered countries which have data for the last three columns, which are the years 2008, 2010 and 2012. So here is my discards tab, which has aggregates in the beginning, and then there is data for which no region is available, and then if I were to go down, I have insufficient data. So let me get back to the Analysis tab. Now Lisa, I have a task for you. You see, this data set begins at row number 4 and ends at row number 162.
Easy. That's 162 minus 4, or 158 rows of data.
You are almost correct, Lisa. But for the fact that you must add 1 to your answer, that makes it 159 countries. I would now like to point out a certain useful feature of aggregating data. For that, let me return to the histogram tab. focus on the table that I used to build this histogram. Now this table tosses any value between consecutive limits into the same bin. For example, the gas price could be 30 cents or 45 cents, and it will toss both of them into this particular bin.
I think that's unfair. Aren't we losing something here?
Good catch, Lisa. So let's suppose that I treat all of the points in a bin as identical. Now, Lisa, which value would you pick?
How about the midpoint of the bin?
Absolutely. So what I'll do now is to move the histogram way to the right so that I'm making space for myself, and I have the midpoint column over here. So as the first midpoint, I will take whatever was this value, add it to the previous value and divide it by 2. That gives me my midpoint. Let me continue this all the way down, and I have those values. Now with this rounding off, I will try to build our new summary measures.
You mean the average and standard deviation?
That's correct. You see, we have grouped our data into bins. So I'll call my group mean as mu. Mu is m in Greek after all. Now don't worry, sigma is Greek for summing up. We've got several bins here, remember? And n is the total number of the frequencies, which is 159 countries in our case. So now say hello to sum product, our new spreadsheet function that does magic. Let's see what we're going to get. So my group mean is nothing but sum product of frequencies, comma, midpoint. What sum product is doing is very simple. It's taking these two columns and multiplying each of these entries in place, and after doing the product, it is summing it up. That's why it's called sum product. So I'm going to divide that by 159. Now I have gone ahead and also calculated the actual mean based on the exact values. And how much was that? Have a look on our spreadsheet over here. All I've done is average everything in the B column, which is nothing but gasoline prices per liter. And I'm getting 1.388 or 1.39. I know what you're thinking. It isn't the exact average, which is 1.39. What do you think, Lisa?
I can live with that.
I must caution you though that the error isn't always so small. But if you're looking for a lower error margin, I would suggest you increase the number of bins. Make it finer.